All right, so for this question here, we're getting right down to it now, proving identities. So again, what I suggest is you, instead of this equal sign, I don't really like this equal sign here. We're trying to prove that it's equal. We're trying to prove that that's an identity that's equal all the time. So I wouldn't put the equal sign in your proof. I wouldn't do that. They're saying prove that this equals this. So that's okay in the question. In our answer, I would just write a solid line here, because remember, we want to remember not to apply the properties of equality across the equal sign or across what would be an equation. So we want to keep everything separate, right? So that's why I just put your two sides here and make a line. Now, one of the tips is to start with the more complicated side. The more complicated side has more terms. It has different trig functions. So obviously this left side would be the more complicated side. It's easier to simplify a complicated side than it is to make a simple term more complicated. There's just so many different ways you can go. It's limited if you're trying to whittle things down. All right, so we look at this left side, and you're going to keep in mind your identities. You're going to keep in mind some of the tips we've talked about already. So sine of 2x and cos of 2x. All right. Now we have identities around those, right? We have identities that are included with those. So if we take a look at those identities, and we're going to have to get back to our page here. So is that going to be here? Okay, here's one page of identities, and this is where the double angle identities are. So cos of 2a, and over here, there's three options, sine of 2a. All right, so what do we got? So sine of 2x, do you see it right here? This would be a great place to start. 2 times sine x cos x. Let's do that. So 2 sine x cos x. See, that's the same as this, using those identities. You see that? Now, why might we do that? Anybody want to tell me why I did that? What is that going to enable us to do later? You see the common factor here, top and bottom? We're going to be able to whittle this down a little bit by dividing common factors out. So we'll just save that. So that's a good choice. Now what about cos of 2x? Remember, we have a sine x underneath here. We don't have to get rid of it, but we might want to consider that. So what do we got? Okay. Well, I have cos squared x minus sine squared x, or I have 2 cos squared x minus 1, or 1 minus 2 sine squared x. What do you think would be our best choice? What do you guys think? Which one? 1, 2, or 3 here? 1, 2, 1. Okay, I heard someone say 1, so let's try 1. Cos squared x times sine squared x. Cos squared x, sorry, I said times, but it's minus sine squared x. Okay. Over sine x. Okay. All right, so I don't know if we're getting anywhere quite yet, but of course we could do what we had suggested earlier. So those coses can go. Can I take one of these sines from the top and one of these sines from the bottom? Can I do that? No, I can't do that. You're right. Why can't I do that? Because the sine functions are not what? Right, they're not multiplying here. They're not factors. So I can't just go ahead and divide them out. They're not factors because of this minus sign. All right. So I've got 2 sine x over here. That's great. Let's write that. 2 sine x. And over here, what do you suggest? We do? Now we have some different options. We could factor this as a difference of squares, right? We could write it as, bear with me, cos x plus sine x times cos x minus sine x. Would that help us to eliminate any terms or divide out any common factors, though? Or would that make things maybe a little bit more complicated? You may not have any idea. Okay, so let me help you with that. I don't know if that would be the best, okay, because we're making factors and we cannot divide any of those factors out. So what's another thing? Can I rewrite, can I rewrite this one? Can I rewrite cos squared of x? Now look back to your Pythagorean identities. You're nodding there. What do you see? 1 minus sine squared x. Ooh. Oh, that is juicy. Oh, that looks good. 1 minus sine squared x. Let's see what that looks like. 1 minus sine squared x minus sine squared x. Okay, well, I like it. Why? Why do I like it? Because I have sine x here, sine x. Look at this is now in terms of just one trig function. Now, okay, maybe this isn't gonna just, you know, scream out anything to us just yet, but let's see where that goes. I can combine some like terms now at least, right? So I have negative sine squared x and negative sine squared x. So, again, don't be lazy, write everything out. It takes you 3 seconds. This is going to be 1 minus 2 sine squared x over sine x. Now, you may be keeping an eye over here and saying, I don't see how we're getting close to this at all. And that's fine. That is totally okay. Sometimes, you got a bit of a winding path here, okay? That's no problem. And maybe someone next to you, you notice that they're able to prove this a little bit quicker than you. Don't worry about it. There's often lots of different options, okay? So yours may be a little bit longer, but if you can get down logically, to where you're supposed to go, it's okay if you take a few extra steps. And again, I haven't worked this through. I don't have the answer in front of me. I'm just looking at this like you are. So, does anything pop out at you guys now at this stage? All right. Does anything pop out at this stage here right now? Any identity, any factoring we can do, any dividing of factors, any like terms? What do you think? You seeing anything there? 1 minus 2 sine squared x. That looks like it's some kind of, there's some kind of identity there, hey? I don't know. Does it equal anything? 1 minus 2, cos 2a maybe, or, right? Okay, so any of this stuff, obviously, if we go back to here, 1 minus 2 sine squared x could be cos of 2a. Yeah, it totally could be. Do we want to do that? No? Okay, do we want to do something else? Do you want to factor this? Do you want to rewrite it as cos 2a? Do you want to go, heaven forbid, back to here? No. What do you think? Well, what are other options? We have some other options. We could make this to a common denominator and combine the terms. That's another tip, right? So if you don't like changing this to cos 2a, because I don't have a cos 2a anywhere else, there's not a 2a here. So what about this? What about if we go, I'm going to make a common denominator here of sine x, and that means I'm going to multiply the top by sine x as well. Now, does that look good? That should look really, really, really good. Oh, lights are going on all over the room here. Okay. And some of you are like, I don't have a light on. What's he talking about? Okay, so look what's happening here. Now I have a common denominator. I can combine the top terms. So, and write a there we go. Another ooh in the back. This is so good, isn't it? It's like, see, this is good for you. It's like, I have no idea if I'm doing this right. I'm taking one step at a time. I'm just doing my best. And all of a sudden, right towards the end, it's like, that's awesome. Okay, look at this. That goes with that. And then we have 1 over sine x. And 1 over sine x, my dear students, is cosecant x. And there you have it. It equals the right side. And of course, now you can write, what are we going to write at the end here? Quod erat demonstrandum. That which was to be demonstrated. We are done our proof. Okay? So if I can get this all on one page here for you, let's see. It'll be kind of small. All right? But that's what it looks like. And you are all going, now I realize why I'm in this class. Because this is so much fun.